Hello everyone, welcome back to Advent Code 2024. Diving into today's just as the problem is published. I don't know, eager to get to it, I guess. So let's see what's going on for day 7. The server might be a little slower than on previous days because it is everyone's hammering it, I assume, but it seems perfectly fine. Anyway, day 7, bridge repair. The historians take you to a familiar rope bridge over a river in the middle of a jungle. The chief isn't on this side of the bridge, though. Maybe he's on the other side? When you go to cross the bridge, you notice a group of engineers trying to repair it. Apparently, it breaks pretty frequently. I assume it broke last time we were there. I don't remember it, but... You won't be able to cross until it's fixed. You ask how long it'll take. The engineers tell you that it only needs final calibrations, but some young elephants were playing nearby and stole all the operators from their calibration equations. Okay. They could finish the calibrations if only someone could determine which test values could possibly be produced by placing any combination of operators into their calibration equations. Ah, it's the countdown game. Countdown numbers game. Maybe. Operators left to right. We have multiply and add. Okay, so it's actually much simpler than the countdown numbers game. Because you have the things the numbers in a defined order, and there's no and the grouping is defined as well. Okay. Sure. Well, that's pretty simple. Now, just how big is our input looking? So, around 10 is the biggest any of these numbers, the size of the list, the biggest list, around 10. I see there's an 11 here, but it's in that ballpark. So, if we only have... Oops. There are only 2 operators, right? Plus and times? Yeah, although I bet that's going to change. Because it says, oh, you glanced into the jungle and you happen to see plus and times. The engineers didn't tell me those are the only operations. So I imagine that'll be something that changes for part 2. But for part 1, there's only around 2 to the 10th, i.e. 1,000, ways you could insert operations into these sets of numbers. And so you can just test all of them. There are a few things to be careful of that I can think of off the top of my head. One is just how big are these ints? I mean, they're pretty big, eh? This looks definitely bigger than a 32-bit int. Where the hell is log? Does log exist? It's got to be somewhere in here. Oh, I see. Log of... I don't think I copied it correctly. I'm not very good at copying in Tmux, so I'm copying with my terminal emulator, which is not the best way to do it. 46 bits. I forget how many bits are guaranteed. Well... Illegal type. Oh, whoops. Yeah, sure. So 78,000. So we have space, in that these numbers do fit into Haskell's large ints, and if we needed to, we could use arbitrarily large integers. But I wouldn't be surprised if some of the stuff on the right, like if you multiplied it all together, it didn't fit in an int. Well, I don't know. Looking at it, they all seem kind of small, huh? Like 10 numbers, let's say they're all 100. That's 2 to the 20? Is that right? Yeah. Which is like a million. It's nothing. It's way smaller than the ints on the left. And even if they were all like 1,000, it's 2 to the 30, which is smaller than the max bound of an int. So we probably could get away with just using ints and multiplying everything. I was just worrying about like, oh, you know, what if you multiply them and they get so big that it wraps around or something, right? But it doesn't look like that can actually happen on the input. Okay. Interesting. You could certainly save some work by abandoning computation if your running total is larger than what you're aiming for, right? So rather than just generating all the ways operators could you could fill an expression with operators and then calculating the value of each of those ways and then saying, are any of them equal to what I want? You could say, you could keep interleave kind of evaluating expressions with generating them. And if you're ever above your target, you could just abort. And that should be pretty easy to do with the list monad, I would think. I'm sure there are some other things you could do to optimize this. I assume for part 2, we'll have to do this somewhat more efficiently, which is why I want to think somewhat about how to do it now. But I don't know. It seems perfectly approachable. So let's just get started, I guess. I think this will be a fine regex applicative thing. I mean, it's simple enough you could probably do it with just like words and lines, but it's easy enough to make it the regex out of this. I want regex, I want match, I want sim, I want many. Actually, what I want is set by again. So I guess I want many also. What day was it that we did set by? Sure. There it is. So we'll want this. Call it set by 1. I mean, sure. What else do I need? Sim. So I need digits. Or decimals. I think that's it. Let's say my. What is this called in the problem? They have operators equation. That's a good one. We'll call it that. Is an equation. An equation of A is an equation containing one A and a list of A's. I'm parameterizing here because that way I can have an equation of ints, an equation of integers, whatever, and I can just change it all in one place if I end up needing to use integers instead of ints. Let's just derive show here. I can't imagine I need anything else. And my input is just a list of equation of int. Oh, you know what's funny? I want to go back and look at day 5 again. So how did we parse stuff here? I guess, yeah, it's easy. Never mind. Maybe if we get a nothing error, just error anything, right? Yeah, error no parse. That's good enough for now. Or for an advent of code problem, really. Because as I said, I do assume the input is well formed for these problems, rather than like doing robust application level error handling for production. Error no parse match input, I guess, where input is, I guess I don't even have to write the type for input, and if I don't have to write the type for RE, I guess. But, well, I mean, I don't know. Input is equation, no, many equation, and then ignore a new line. And call input on that. Is that it? Yes. I don't know what I was thinking. Yeah, input of many equations. An equation is equation of a decimal ignoring, well, I want to ignore colon and space. So maybe I actually don't need set by now that I look at it, because I can just handle the spaces as leading spaces here. Oops, this is the wrong file to edit at the moment. Where am I? Here we go. So if I don't need set by, it's an equation of parse a decimal and skip a colon, and then many, skip a space, and then parse a decimal, right? I think that's it. Oh, I never even, yeah, that's true, sure. I don't need to wrap this in input because I didn't, it's not a new type, it's just a type alias. Okay, cool. So if we said prepare of, you know, this number 1, 10, 20, new line. Great, looks good. And just to be sure, let's say we had the same thing twice. Yeah, it successfully parses it twice. Okay, so main, I mean, okay, I guess it doesn't do anything. Yeah, honestly, I don't really need this, it turns out. Match sim many decimal, that's all we need to parse. Great. So let's see. Let's say data operator. I'm a little bit concerned that when I define a list of operators here, I'll find out in part 2 that there's a new operator or something, right? And it kind of stinks to have encoded at the type level a specific set of operators. And then it'll be difficult to disentangle the definition of operator for part 1 and the definition for part 2. So maybe what I will do... Maybe what I will do is I will define a type level set of all known operators, but I'll have part 1... I'll have part 1 only look at, like, rather than just considering every operator that exists, I can make it just use the 2 operators that part 1 cares about, I guess. So let's do that. Data operator is either plus or times. And I guess it wouldn't hurt to derive, like, enum and bounded. And those are the types show for sure. Those are the types you could, or the type classes that you could use to just ask the type system, hey, give me a list of all the operators that exist. But I think I won't do that. Data, no, not data. I want to define a function. Apply? I don't know. Up? Sure. Well... takes an operator and returns a function that takes 2 A's and gives you a new A, provided that A is numeric. Apply plus is plus, apply times is times. So let me see. They're asking me what they want to know. The sums. Okay, the test value is the number on the left, right? The test value appears before the colon. Yes. Okay, so they want to know the goals of all the sums of the goals of the operations that can be satisfied. Part 1 is sum map may be satisfiable of plus and times. Right, that seems fine. So satisfiable will take an equation and return nothing if you can't satisfy it, and return the goal if you can. Where... I kind of want to make that a top level thing, I think. Well, I don't know. I think it belongs as part of part 1, and part 2 we may reuse it, and if so, we can extract it to the top level, or we may not. But it kind of feels internal here because it's doing this weird thing where it returns a maybe event instead of like a bool, which would be normal. Satisfiable of ops and an equation goal nums is go Well, really, I need the first number, right? Okay, let me make sure I understand the rules for how you're supposed to combine these things first. Operators are value left to right, not according to precedence rules. Numbers can't be rearranged. Uh-huh. Okay. So we'll assume there's at least one number here. Go goal nums. Well, I guess I could have the goal be implicit here, right? We already need implicit access to ops, so let's take implicit access to goal as well. Go of total. Total equals goal equals just goal. Total is greater than, well, actually, shouldn't I use case compare then? Yeah, I guess so. Well, not exactly, because I want to say whether or not there are any numbers left in the list. If we've met the goal, then return the result. And if we've exceeded, then give up. But then have a separate pattern match. If it's empty, it's also nothing, because we have not met or exceeded the goal and there are no numbers left. And then finally, go total of xx, or nums, I don't know, xx's is fine. We can assume in this case that total is smaller than goal. It's smaller than goal, and so we should continue. And so there's got to be some function that takes, like, I don't really want to be working with maybes here. I want to be working with a list. But I gave myself maybes, huh? I'm sure there's something here, though. Let's see. It's probably cat maybes or something. Well, no. List to maybe? I mean, these all... This isn't quite what I want. If I had a list of maybe A, and I wanted a maybe A as result... First justs? That's in data maybe. Okay, that's interesting. Takes a list of maybes. And... Oh, but this is in GHC data... No, what is this? GHC.data.maybe. I want one in data.maybe. Like I want one. Isn't there? First is a yeah. So data monoid first returns the first non-nothing. Data semigroup first. Returns the first value. What does that mean? I guess the idea is if you had two justs, it gives you the left value. That's okay. So what is this? Yeah, so this, they both have the same reminder. Huh. I don't, I think I want the one in data monoid. So maybe we're not using. Oh yeah, and here I can just say, here, let's do it this way. Import data monoid. First. And where is coerce? I don't know, I'll just import run first, it'll be fine. Actually, that's probably coming with first, isn't it? Get first, yeah. Okay, fine. Get first of this. And are these both just wrappers around? Yeah, so it's first of just goal. First nothing. And then I'm going to produce a list of results, and I want to m-sum them up. That's okay. That's got to be in data monoid then, or mconcat. That's probably in prelude. Yeah. Okay, that's what I meant. What is m-sum? Is that anything? I don't know. So now I want to produce a list of first of int, I guess, right? So we'll choose an op from the ops. And I think just call total, no, what am I saying? Go of apply. The left side should be the total we've already accumulated. Apply op. Oh, I do want parents there. Apply op total x. X's? Is that it? Let's see what the compiler thinks of this. Not impressed. Map maybe doesn't exist. Well, that's true. I'm not using map maybe. Oh, yeah, I am. I'm coercing to maybe at the end here. Okay, so Let's get that from here. Of course, there are other issues, and they are... I have... Oh, I probably need to say pure of this, don't I? Okay. Okay, those are good warnings. This one I'm choosing to ignore. This one, line 26, go total empty. Yeah, that's true. I'm choosing to ignore total on purpose. So now this compiles, and the only warning is one that I intend to be wrong. So what do I get if I run main? Is it a number? It is a big number. It's a really big number, but we knew it would be big. So I can just go put that in, but I think I'd like to review what I've written here first. So for part one, we call map maybe, getting for each equation possibly a number, that number being derived from satisfiable plus and times. Satisfiable of a list of ops, and it takes a single equation with a goal and a list of numbers of length at least one. And I'm sure there's something more sensible than using first and get first and mconcat here, some way to... Like really, if this just returned a list, and then I called list to maybe on the results, that would just be way simpler, wouldn't it? Yeah. Because then I'm basically actually calculating, like, how many ways are there to choose operators for this number, this equation to be satisfied? And then if I find the first, and I can... But I don't have to look at all of them. If I only care that there's at least one, I can throw it away. This is way better than this whole data monoid garbage. I don't even need map maybe, do I? I don't think so. I don't need data monoid. I don't need any of this junk. So satisfiable, really we should call solutions now, because we're actually computing all of the solutions and then throwing away all but the first. And because of laziness, this won't actually cost anything more. So solutions of ops, yeah, that's all fine. So we'll just say go num nums. Okay, so now I can just say it's the goal. And I don't know. I guess this is kind of weird because all of the entries in the list are just going to be the numbered goal? Okay, I mean, I guess this is still a little bit silly, but... So I think this makes sense. We choose an op, and then we call go, which returns a list. Yeah, okay. So does this type check? Almost. List to maybe... Oh boy, they're gonna call the cops on me for this one. So the joke here is we're calling sum on a maybe, which for nothing returns 0, and for non-nothing returns the value that was there. Because list to maybe doesn't return an int, of course. It returns a maybe int. And we want to convert that into a number. And, you know, some will do the job, but I think you should be thrown in prison for calling sum on a maybe. But here we are. Okay, so if I run main here, do I get a similar number? Of course I do. Because the answer, the program was right all along. How could I get a different number after writing 2 correct programs? So what do they think of this? That's not right. All right. Retracted. My confidence is retracted. Well, okay, so one thing we could do would be to test part 1 a bit. Part 1 of a list of inputs. Input 5 and 2, 3. Surely this will say 5. Right? It's not called an input, it's called an equation. It does say 5. And if I said an equation of 4, where you just get 1 and 1, it still says 5. So it's doing roughly what I wanted it to do. And if I like added another 1 here, it would then say 9. It doesn't. That's true, there's not enough ones. I would need this. I was thinking I could add 1 and 1 to get 2 and then multiply by 2 by 2, but you can't do that when only has 1s. So there's numerous ways to satisfy the second equation. Right, you could add 1 and 1. Oh, maybe there's only one way, actually. Because we can't, like, regroup things. Add 1 and 1. Multiplying that by 1 doesn't do anything, so you have to add again, and then you add again. Okay, fine. But if I said, like, 2 and 2, it's still just 4, right? Yeah. Okay, so, I mean, this looks broadly correct. Okay, so let's look back at the... So here's the input, the test input. I mean, we can just run this, I guess. This looks fine. $37.49. That's correct. According to the website. Just right there. Well, that's sort of annoying. What should I do then to investigate what might be wrong? I didn't accidentally screw up my input file, did I? I guess it's impossible to tell. I did like do some paging through this. Maybe I don't know. Let's, just out of curiosity, day 7, please. They're the same, yeah. So that's not the problem. All the test inputs are fairly short, at most 4 numbers. Well, let's wonder if perhaps there is a problem with integer wraparound or something. One of the ints is too close to the upper bound of an int and it wraps around at some point. And then, like, I should short circuit because I went over the goal, but actually I wrap around to go under it. And then I still somehow find some way to, yeah, that seems unlikely. Well, let's leave the test input in for now, I guess. And say I want to use integers. And then we'll convert it back down to sums, to ints. Still says 3749 for the test input. And for the real input, I mean, that looks like the same number I had before, right? Ah! Of course, I pasted thinking maybe the number I had entered before was in my paste buffer, but of course it wasn't. What was in my paste buffer was the test input. 303, I mean, it starts 303, ends 419. Oh, right. This is the most recent one I got. And if we scroll up a bit, yeah, it looks like the same number. So it doesn't seem like switching to integers made a difference. I guess actually it would have been a little bit more accurate to do this so that I don't ever have to go down into ints. And I guess we can rerun that, but no, it's the same. Okay. Actually, not that this is important, but it is probably better maybe to put times first, because I don't know, that'll more quickly lead you to outpace the input if anything does, and so you can prune more quickly, I would guess. I don't know. Maybe it doesn't matter. So we have a total and the list of all the nums. We opt the total with the next number and continue with the rest of the numbers. This all seems fine. And no matter what remaining numbers there are, we first check whether we've met or exceeded the goal. So it's not like we're early failing because the list of numbers has run dry and we happen to already have exactly the right answer. We're not testing things in that order. I will say I've written this go function in a slightly bad way. Let's do it better now. Let's say we have nums here or something. Is case compare total and goal of. If If the total is equal to the goal, then we just return the goal. If the total is, if the total is greater than the goal, then we return nothing. And if it's less, then we can say case nums. Nums of if there are no nums left, then fail. And if there are any left, then do this. Now, do I actually need, I don't think I, do I need parents there? I feel like I do not. No. Which binding of nums shadows another one? Oh, I see. Nums is in scope here. Call it atoms. I don't know. Whatever. So this is going to be the same number, of course. So I haven't fixed anything. I've just written it in a way I like better. It's very clear that we're matching what we do in every case, as opposed to like kind of some little magic. I think it's longer than it was before now, but that's okay. I don't understand what I have wrong here. And it works on the test input. I really don't want to just enter the same number again like an idiot, just in case I made a typo while copying it or something. I don't know. I have an equation. I mean, what do you even do here? I can come up with some more test cases, but so if we go back to the test input, like I could put a 1 here, right? And this shouldn't change the result. Let's confirm that that much is true. Yeah, it's still 3749. So although let's put a couple zeros up front so that there are definitely multiple ways to solve this, I guess. You could start with 0 and multiply by 0, or you could start with 0 and then add 0, and then the 10, 19, and 1 kind of handle themselves. I don't see how that could make a difference. Yeah, that's still correct. Is my parsing wrong? If it were, I would be getting some kind of error, right? I mean, I have this no parse error. So we match an input, and input is many. So match input means that the entire input string has to be matched against the regex called input. So if a single character there were not recognized, I would be getting no parse. Like, for example, if I went to my test input and put... Oh, Emacs won't let me put an extra space at the end of the line because I have it set to automatically clean up. But if I put like an extra space here, it'll blow up on me. Yeah. So like it definitely is parsing the entire input. I mean, I guess we could confirm like how many equations there are here to make sure we got them all. Length prepare of read file input.text 850. I mean, that's right. There are 850 of them. There aren't like any negative numbers. That would certainly be a thing that would be problematic for me. Yeah, there's no minus signs in the whole file. All right, well, I'm going to take a break and think for a bit, I guess, rather than sit around watching me stare at this and do nothing, and I'll let you know how it goes. I'm back with no great new insights. I did make a couple small changes to part one, or to the go function, I guess. And they aren't very interesting, but I changed it so that... I don't know. Like, so one thing I thought of was maybe there's a 0 in the input, in the operator list for one of the equations. And then multiplying by 0 would be a way, like, I'm currently pruning if I get above the goal. But if there were an equation where, like, the goal is 1, the first number is 7, and then there's a 0 and a 1... I'm pruning after getting to 7, but actually you could take 7, multiply by 0, and add 1. But I checked, and there aren't any zeros in the input, so that's not the problem. But that is a thing that, like, I don't know, that I could be doing wrong here. The other thing is... well... I think that's the only real change I made. But what I wanted to do, I'm back, but I haven't figured out the answer. Why am I here? I thought of something to do that would at least make it a little bit more transparent what's happening, and I think just make more sense overall. Is we've got this kind of weird, like, you know, the go function is returning a list of solutions, but each solution is just the goal. Which doesn't really make any sense. I just did that because I wanted a convenient way to get the goal out in the solutions function. And so I think it would be quite a bit nicer if we had a solutions function that returned a list of all the ways you could solve the problem. Right? Wouldn't that be cool? So how exactly would that look? We could return a list of the operators that we chose. But that's not exactly... diagnosable. Like if I tell you, oh, I solved the problem, it was plus times. You have to go back and look, like, what were the numbers I was adding and multiplying to confirm that it's right. So it would be sort of nice if it could return the entire equation that it used. So, like, that's an interesting solution. That's an interesting type, isn't it? So what if we said data solution is a solution of... Should I include the goal here? Probably not. A solution of A is a solution containing an A and then a list of pairs of operator and A. Right? And we'll just give that show. And we'll take solutions and make it a top-level function. Actually, I should copy it like this. That produces a list, an actual list of solutions. Takes a list of operation and an equation of A. Requires that A be a number, I guess. And returns a list of solution of A. So that's a little bit trickier. But I think it's okay. We can say solution A mapped over calling go num nums. Does that make sense? I think so. So first of all, I don't think it makes sense really to call goal cons to more if we're equal to the goal, unless we also continue in this case. So really, this whole thing, like, honestly, never should have been extracted out of its own value, unless I wanted to handle zeros in the input. But I don't really, because there aren't any. Maybe I'll have minuses in part 2 or divisions, and then I'll have to revisit this where we don't prune. But for now, we'll still prune. So if the goal is too big, yeah, if it's equal, we say, yeah, there was one way to do this from where given the choices we've already made, there's one way to do this, which is to stop here and not add to the solution. And then if we have more things to do, we should say, let's see, op x cons, and then map that over the result of the recursion, right? So do the recursion, and then to each result, cons op x. I think that makes sense. Does this type check? They're called operators, apparently. Sure. Operator. Yeah, the solution is not A, it's num. Couldn't match solution integer. Oh yeah, because part 1 isn't using the right result anymore. So I guess we'll just call it where score of equation goal nums if null solutions times plus eq is 0 and otherwise is goal. Does that make sense? I think that looks okay. Nope. Oh. Yeah, we do need that the goal we're building up to is orderable. That was implicit before because we were producing an integer, but now that it's extracted, I need that a is both a number and orderable. Good. I don't need list to maybe anymore. So now if I just said like okay, so this produces 9, really? Yeah, 9 things. Okay, just checking, just keeping you honest. Let's say this is so now we can look at the test input and it's all these things. So what if I were to map solutions over test input? Oh yeah, sure. The solutions of using times and plus, please. Yeah, it would really be nice, wouldn't it, if the solution included the goal number, wouldn't it? Okay, fine. No problem, no problem. So we'll put 2 A's in there. And just say goal, and that ought to fix it, right? So 190 is 10 times 19. 3267 is 81 times 40 plus 27, or 81 plus 40 times 27, which is called out in the problem statement as an example of how you could do this 2 ways. Then there are no ways to solve the next several. And then 292 is 11 plus 6, that's 17, times 16, which must be 272 plus 20. Yes, that's correct. I affirm it. I'm reminded that a week ago I was talking to my nieces and they were practicing multiplication problems of, 2 and 3 digit numbers. And I couldn't just multiply any old 2-digit number in my head that quickly. But 16 times 17 is pretty easy if you're a computer scientist, right? Because 16 squared is 256, and then you just add 16 to the result. Just kind of funny that I happened to be like, oh yeah, of course. Oh no, we're multiplying 2 big numbers. What am I going to do? Oh wait, never mind. They're 2 big numbers that I know the multiplication of. So this looks perfect. We could say, just read the real input. And, who knows? Is this right? Let's pick one at random and see if it's true. A smallish one, please. No, this is not how you search backward. $31.02. That's one I could maybe do. 13 plus 318 is 331 plus 676. 331 plus 676 is a 7. 1107? No. 1007. Yeah, 1007 times 3. That would be 3021. And then we're adding 81. 3021 plus 81 would be 3102, and that's the goal. So yeah, that's, I mean, that is a solution to that problem. So this testing here has me thinking that I do indeed well, actually, let's do something else. Why is it? I can't. Whatever I just wrote, I can't get back. Whatever produced this. So I guess it was. It was probably just part 1, right? No. Map solutions of input, right? Not quite. Yeah, okay, so that's a thing. And what I want to do is define that. You don't have to write let these days anymore, do you? Solve is this. Find me all of the things that it found multiple solutions for, please. There's only a couple. In fact, there's only one? That's a little suspicious. Oh, I said greater than 2. What I meant is greater than 1. Okay. So there's a few that we find 2 solutions for, and only one that we found 3 solutions for. Maybe this is what part 2 will ask us for. Just add up the numbers for the ones that that there were multiple solutions for. Wouldn't that be nice? But so, like, let's audit one of these. 4758. I don't know why I'm auditing this. What is the point? But we start with 74 and add 19. That's 93. Times 51. Oh, man. Well, I can just ask the computer, can't I? Yeah, let's do this. 74 plus 19. 19 times 53. 51. Plus 14. Times 1 plus 1. Okay, I'll skip the times 1 if that's okay, and then add 1. 47, 58. So yeah, this is fine. And then there's apparently another one where you add 19, multiply by 50. Oh, sure. It ends with times 1 plus 1, but it could have ended with plus 1 times 1. That's fine. Okay. So that seems legit. So let's do something stupid here and just say let's get the sums. Let's do the summation again here on just the solutions, right? So what exactly does that look like? I want to write sum of map sum dot list to maybe, maybe list to maybe, because it's not imported, of well, no, I don't even, yeah. I want to get the first item, so map score of souls, score of solution goal anything equals goal score of anything else is 0 in right, this should not be a list. I guess it probably should be parenthesized, though. This is the same number. So, like, there's not something wrong with our summation mechanics. All right. I mean, I guess I'm going to copy this and see if I copied it wrong last time. And then maybe I'll just make a note so I don't ever have to do this again. Number submitted is not that, but this. Oh, it says it's too high. I feel like it didn't say anything about it before. I must have just skimmed over that. Okay. Too high. Well, I guess one thing we could do is, since we have all the data from each solution, we could verify it, double check, is it correct? Because if we're getting too high an answer, that must mean, like, that we're including the score for something that shouldn't exist. Oh my, wait, no, this is right. I was like, otherwise equals goal. Oh my gosh, you dummy. Like, you're adding goal every time. But no, that's not the case. So if the list of solutions is empty, that's what null means, then we score it as 0. Otherwise, we score it as goal. So we've taken our list of, and we have the correct number of equations. we have the correct number of equations, and our score is the sum, or our total is the sum of mapping score over the inputs. So there must be at least one input where the score I'm assigning is higher than the score it should get, right? And since the score for every equation is either 0 or the goal, and 0 is never higher than the score it should get, then there must be an equation in here somewhere that I'm saying is a solution, but actually it isn't. Right? Like, how else could I be wrong? So one thing we could do is write a check function that takes a solution and confirms that it's valid. And then we could check every solution that we got and see, are any of these invalid? If they're all valid, that would mean I've misunderstood something about, I don't know, how you're supposed to score this stuff. Like, I'm pretty sure, since we got the test input right, we're scoring this number only for solutions that have at least one, or equations that have at least one solution. Okay, so fine. Let's do that. Let's write validate takes a solution, and I guess it just produces a bool? Validate, well, I mean, really it ought to, like, compute, right? I don't know. I'll just say validate. Validate of solution of goal num nums is go. Oh, these aren't nums though. They're steps. Oh, and actually, hang on. Equation goal. No, they are nums. What's in a solution? Okay, a solution has. What are these two A's? The goal and the starting number. Okay, fine. Start nums is go start nums, right? Is that it? But they're not nums. They're steps. Where go of total, I guess, empty is, so there's no operations left to perform. Therefore, is the goal equal to total? That's whether the solution was right. Go total of op x cons to more is go of apply op total x more, right? Solution of A, I guess, sure. A or A. That's true. So let's amend part 1 here. Equals, let something. Let sols equal the solutions for times plus and the equation. No, you know what? Let's I don't need to do that. Case solutions of this equation of, if it's empty, we can just turn 0. So if it's any other solutions, and not null, any not validate of solutions is error show solutions. Otherwise, it's goal. Does that make sense? So if any of the solutions are invalid, then just print all of them. And if they are all valid, then it's just the goal number. That seems reasonable. Fails to parse. Oh, right. When you use a pattern guard in a case, you have to write an arrow instead of an equal sign. Fine. What are you saying? Oh, right. Not solutions, but sols. Solutions is the function. Sols is the solutions we've computed using the function. Could not deduce num a. What? Come on. Tell me what function I called with the wrong number of arguments, please. Oh, fuck you. Oh, again, it should be sols. Got it. Okay. So let's run main, and it says 3479. It didn't find any errors in the test input, which makes sense because we got the right answer for the test input. So what if we did this? Ah, they're all correct. So I don't think I'm misunderstanding what it means to apply operators from left to right. Yeah, I mean, because, for example, in this input here, I did this by hand and got the right answer, and it's the same answer that, like, 11 plus 6 times 16. If you just wrote this into, like, a calculator or a programming language, it would multiply the 6 and the 16, which is not what we want. But 11 plus 6, that's 17, multiplied by 16, that is what we want. I did that by hand and got the same result as this, which is correct, which is also the same result my program got. So I don't think I'm misunderstanding what it means to apply operators from left to right. So what am I getting wrong here? I checked all of them. For each one, every solution is valid. I summed them up, and the number is too high. I'm using integers, so there can't be any, being too big for the container type, for the int type. Like, Hello? Is Advent of Code broken? I don't understand what I'm getting wrong here. I'm going to go away for a while again, I guess, and think some more. Okay, I finally figured it out. I'm so stupid. You guys have been shouting this for hours. The problem is, I'm stopping early here. I have found a way to add up to the goal. But that doesn't mean this is correct. And the reason my validations are wrong is that, like, I threw away the assignment and then turned in a different assignment and said, look, my answer to this is right. Which was true, but that wasn't the problem I was assigned to solve. The issue is, right, if I add, like, if the goal is to get to 2, and the input is like 2, 5, then there's no way to do it, right? But my solutions will say, oh yeah, sure there is. Just stop at 2. No problem. Well, that's not correct. You have to apply the whole list. Okay. So I haven't written any code to confirm this. I just, as soon as I realized what was wrong, I was like, all right, I'm getting back on this stupid problem. Okay, so here's the problem. I had this clever idea of stopping early, but really I should say case atoms, I guess. Like, if it's empty, then you solved it. Otherwise, like, better keep going. What's the best way to say that? Like, if it's really, maybe I should pattern match on. No, I should check this grader first so that I can prune and exit early. There's got to be a nice way to do this. I looked on the subreddit and saw someone's solution in Python. I was like, oh yeah, this is exactly what I'm doing, except that instead of having a separate total number, they were checking if the list has at least 2 elements, and if so, combining them into one element and putting it back into the list, which, would be fine. I don't think it's any better or worse than what I'm doing, really, except that it requires you to keep validating. Like, you have to keep. You add something to the front of the list and then you take it off, and then you add it and then you take it off. And it's like a little bit inefficient, but not as much as doing completely the wrong thing like I am. So maybe what I should do is this. Eq and null atoms. Then we return nothing. So if we found the goal and we're out of items, we can return nothing. There's going to be a little bit of wasted work here, though, like, because what you could do is this, right? Say, okay, and if then fall through into this case, either because the answer was not equal or there were leftover items, and keep going. This will be correct, but it's a little bit unpleasant having to check whether atoms is null and then later do another pattern match on atoms. I don't know. I think it's fine. If I run this, I do get what looks like a slightly smaller number. 303,876,4 instead of 303,876,5. So it's smaller by like 100,000. There's probably like one thing where that was okay, where my error caused a problem. So let's write this in. Okay, and by the way, since I was on the subreddit, I know what part 2 is going to be. Should be pretty simple. But let's commit this. Ugh. Delete this. I mean, validate is kind of nice, but it doesn't actually work because it doesn't actually take in the solution, right? Or the original equation. It just validates you produced some valid expression, not one that you were asked to produce. So I think I'll just throw it away. Is goal otherwise equals 0. So get rid of all that, get rid of all that. Apply solutions, part 1, that all looks fine. So just to check, if we run main again. Uh-oh, it's too big, it's too big. Oh. If it's null, it should be 0, otherwise it should be goal. Try again. Yeah, that's the right answer. Okay, so git add. I assume we're committing all of this, but I do like to check. Yeah, it's just like the whole can't split this hunk because it's already split. Yeah. Day 7, part 1. What a dummy. All right, back to the problem. The engineers seem concerned. The total calibration result you gave them is nowhere close to being within safety tolerances. Just then you spot your mistake. Some well-hidden elephants are holding a third type of operator, indeed. The concatenation operator combines the digits from its left and right inputs into a single number. For example, 1, 2 concatenated with 3, 4, 5 is 1, 2, 3, 4, 5. All operators are still evaluated left to right. Yeah, so the way that we wrote the program, this is going to be trivially easy. We'll just define a new operator, cat, and apply cat sure, we'll do this the fancy way. Is, well, there's not actually, you should just do it, okay. You should just do this in the way that is not stupid. It's read of show A, show B, right? And you need to add new constraints here, of course. Read A, show A, and also still noon A. So I was thinking of doing this in a cute way that isn't actually like more readable at all, but it is kind of funny. Is to, well, so this pattern here of take two arguments, apply one function to each of them, and then apply another function to combine the results. That's called on in data function. So we could say, oh, this is concat on show, would be this part of the expression. The annoying part would be to then compose read with the result, to write this in a point-free way. And you can do it. You can say compose with read, compose of concat on show, right? Like if you import data function on functoin, I do that all the time. Oh, whoops. Like that. All right. Couldn't reduce read. Oh, sure. Read A, show A, and all these things. Sure. So this all works now. And if I said apply cat to 421 and 98, it says 42198. So isn't that cute? What a fun little way to write this function. But it's obviously way less readable than just doing this. So we will do it the non-insane way, but I did want to show off the insane way a bit. Okay. So we'll just say solve is a function from list of op to input to integer. Solve ops is this. Ops part 1 is solve of times plus part 2 integer is solve of times plus cat, right? I think that's it. Apply has different numbers of arguments. Oh, that is kind of funny, isn't it? Okay, fine. Equals lambda AB. Because there isn't a built-in operator for this. You have to use the same number of arguments for all the equations in a definition group. And this should be a little slower, but you wouldn't think that much slower. There were around 10, so like 3 to the 10th. I mean, that's bigger, I guess, but surely not that much bigger. Just in case it takes a while, let's run stack run and get it compiled instead of, oh no, it's done. Okay. So that's a number. And somewhere in here while I was thinking, and you guys were gone, I did compute what is the total of all, like if every equation were valid, what would the number be? And this is just a quick little sanity check. Is that greater than this? True. So we have achieved a number, and it is smaller than if all of them were valid. So that's enough for me. I'll try submitting it. That's the right answer. Okay, so it was a very simple problem, and I made an error very early on in a way that it was completely cloaked from my vision and didn't appear in any of the test inputs. It would have been easy for Eric to include a test input that would trigger this kind of bug, and I think he does, generally speaking, try to put stuff in the test inputs to handle, to trigger common bugs, but this must be a bug that only an idiot would write, I guess, if Eric didn't think of it. So, what can you do? Yeah, this all seems... I mean, it ended up being kind of annoying to have solution parameterized when I assume int would have worked totally fine. Right? All of these should fit inside of a Haskell int. Score also... What? Oh, because the goal... Yes, I have to also change it here. Oh, and of course this is going to take a while. But it should be the same result, right? I don't think int wrapping is an issue. Yeah. So I could have just used int the whole time and everything would have been fine. But I think it's nice to have this flexibility where you can just change your program in one place, or eventually two, because solve and part 1 output that type as well, to try a different numeric type if the one you chose is a problem. So it's fine. All right. Let's get this committed and get out of here. What did I change? Oh, right, I changed. Oh, I guess I should leave these as integers. There's no real reason to make that change as part of the part 2 commit. So yeah, change to operator, change apply, change the context for solutions, extract solve, write part 2. Yeah, okay. Day 7, part 2. Oh, what a sad, sad day for me being stuck on this. Because it's natural, like when you're writing a search problem, which is what this is, a search algorithm, usually, like, when you hit your goal, you say, great, I'll just stop. And I didn't think long enough about whether I had hit my goal here. But there were more numbers to come. And you do have to use them. So this isn't a goal until you're done. So I don't know. I just should have thought more about what that meant. I'm glad I figured it out eventually. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.